let's start. Today we have actually third lecture. Today we have our third lecture, which is related to medical informatics part of combined course. And the topic of today's lecture, decision support and expert system in medicine. That's actually overview of possible application, usage, and technologies behind these terms. Main question in today's lecture, it's the basics definition about what is decision support system as kind of information system. Then consider application decision support system in medicine, and a little bit introduce ourselves into expert system and modern achievement in this area. And finally, if we will have enough time, a few words about artificial neural networks as one of the techniques which give us power to develop decision support and expert systems. Let's start with first. So definition, before we will consider exactly decision support system, we have to check definition of information system in general. I also recommend for you to check additional lecture which is published in Moodle about various type of information system and their application in medicine. So then, we will pay some attention for classification, types of decision support system, and so on. Okay, let's proceed. So in general, information system be considered as combination of information technologies, people activities that supports operation management and decision making. So actually, more widely, term information system used to refer interaction between people, process, data, and technologies. So here is its key points. And we talk about information systems. Sometimes people think it's only computer systems. No, it's important to understand the interaction between three. So it's have to be all information or technology component as well as the human activities involved at every time. And when we consider components of general information system, here is four main parts, which is of course hardware components, hardware software components, like computer system, application software and upon it, then networks which allow computer system to interact one to another, but next pair of components, it's definitely data which is have to be processed with an information system. So raw fact, informed database, or numeric text, video. So anything we need to process, but also people's stuff and users. So again, here is I sign. It has to be both professionals as well as ordinary users who utilize all these hardware, software components in order to process data, in order to turn data into information, like something meaningful for our areas of activity. So here is important to every time keep this in mind, that users are part of information system as well. And in today's lecture, we will concentrate in these selected areas of classification of information system in general, which is related to operations support system, management support system, and knowledge or processing system, third row, which is not entitled exactly because it's actually on intersection of support of business operation decision making. So as you can see, we have large families of different type of information system, and only this like four or pair we will try to cover, because like decision support system, executive information system, it's little to no difference between them, dependency circumstances or sometimes present, significant. Same way expert system and knowledge management system, they are quite similar and not in all cases being distinguished clearly. Okay, regarding to term decision support system and their understanding, let's take a quick look into history to see how it's changed and how it's come to something more or less modern. If we look like 50 years ago, we will see that DSS, it's model-based set of procedures for processing data and judgment to assist manager in decision making. So here is nothing spoken about system. In fact, just procedures, and like nothing spoken about computers here and computer systems, which is pretty obvious. But even 10 years later, definition of decision support system had been already updated. It's extendable system capable of supporting data analysis and decision modeling oriented toward future planning, use at regular and file intervals. So here is a procedure is being replaced by systems. So it's meaning maybe some kind of computer system had been involved, but still just oriented toward future planning, use it at irregular intervals, so not every day. Yes. And at the end of 20th century, we come to first simplest and still actual definition of DSS, like computer-based systems that aids the process of decision making. So here is we have starting from that time, from 1990s, so we have meanings which is close to modern. And like more bit extended definition of DSS could be seen as interactive, flexible, adaptable, computer-based information system, especially developed for supporting solution in non-structured management problem, for improved decision-making, utilize data, provide easy-to-use interface, allow for the decision makers own insight. In fact, in this definition, given majority of features and given majority of features of DSS as kind of computer-based system listed and provided, and also signed kind of problems that have to be solved with help of it. So very good definition despite its age. So finally, if we talk about something more modern or current understanding, we can see the decision support system as computer-based information system that supports business organizational decision-making activities and management, operational planning levels of organization, helps make decisions, which and so on. Here is important to understand that we can that the decision support system could be or could work in fully automatic mode, but also being in cooperation with human staff, like some kind of combination of both. Here is chart of conventional how we can represent the decision-making system, and especially in comparing it with management information systems. So here is given important difference, unlike management information system, which also process organizational data and provide any kind of turn data into some kind of information by creating reports, charts, and some other visualization. The decision support system made next step and generate some kind of recommendation or suggestion about solving given problem, which in turn could be objective for what if analysis, like what we will do if what would happen if we will make this decision. And in case of application of it, it's again become we will got possibilities for some quantitative analysis techniques, and then refine our decision-making process again and again. So here is within management information system, we have meanings that only designated staff manager made decision, but decision support system, when we extend our tool to decision support system level, it provide us kind of suggestions that could be accepted or rejected depending to situation. As I already noted, the critical features, critical characteristics of DSS already listed in one of the definitions, had to be interactive, had to be flexible, and had to be discovery oriented and accessible for designated staff, of course, not for everybody. And when we compare again management information system and decision support system, which actually some kind of level sounds a little bit similar, but still we have significant point of differences between those kinds of systems. And with MIS, please don't mix management information system with medical information system, which use same abbreviation, but it's different, have different purpose. And in this lecture, I mostly use MIS abbreviation to determine management information system, not medical. So, kind of what is difference between MIS and DSS? In kind of decision has been provided, MIS oriented toward information about performance of organization, when DSS provide information technique to analyze given specific problems, sometimes very complex kind of information and information form, frequency, habits, and be used. Like MIS usually provides some kind of exception report on given periods, like weekly, monthly, or so, when DSS used to interactive inquiries and response, and could be used even on daily basis if necessary. So formats every time MIS-DR usually with pre-specified fixed format, which is based on top of organizational databases and transactional processing systems, when this SDR with ad hoc, flexible, adaptable data formats, and even up to free speech recognition, text mining, and so on, and information processing methodologies. So MIS DR with information produced by extraction and manipulation. So basic analysis of business data, like for example, statistical analysis. So here is a good point for management usage of management information systems. Here is decision support system produced by like analytical models of business data and so on. For example, like let's consider something like regressional analysis. So here is, despite it's based on its nature on statistical analysis, but it extended, and here is kind of predictive techniques give us relation to analytical modeling. Okay, let's continue with classification and consider more detailed various DSS taxonomies. So by using relationship with user could be differentiating to passive, active, cooperative. So obviously passive just provides some aids and recommendation, and active can bring out decision, suggestion, solution. And cooperative allow decision maker to modify, complete, and refine decision suggestion provided by system before sending back to the system for validation. So it's like a step-by-step process. So when user provides some initial data, retrieve suggestion, added more hints or more points, send back to system, then system respond with improved solution, improved recommendation, and this loop will be repeated again and again until it gets some successful results. Okay, mode of assistance: communication-driven, data-driven, document-driven, knowledge and model-driven DSS. So in fact, some of those things, in my personal opinion, even not exactly related to DSS, for example, communication-driven DSS, but okay, by authors of textbooks that I have used it as source of lecture, it is. Here is, it's a relatively old book, but still applicable. So communication-driven DSS means support more than one person working in shared task. So any kind of, in this meanings, any kind of communication platform, even Teams, for example, could be seen as communication-driven DSS. In this case, of course, decision has been made by actors, by staff which assembled, which joined together in communication platform. But so, because platform technical stuff allow us DAO to and work together, okay, in some meanings it can be seen as DSS. Data-driven, data-oriented DSS and manipulation of time series of internal company and external data. Very good approach. Again, as example, we can see some attempts for perform regressional analysis even by using spreadsheet. So in this case, spreadsheet could be seen as kind of DSS as well, depending to what exact kind of analysis you conduct by using spreadsheet. Model-driven and fast process manipulation, statistical natural simulational model. Of course, so before this, we have to obtain such kind of model in form of usually some mathematical equation in some way. So in this case, under model, we will have meanings of mathematical equation, or it might be also made of some logical statement, logical formulas, and so on. And here is my chart, which have to give some differentiation between data-driven, model-driven DSS. So data-driven means we have to large amount of data, which is have to be same way analyzed, and important insights have to be retrieved from this data. For example, by lab techniques, data mining, or any other approach which allows to deal with large data set. And with the model-driven DSS, we process this data by applying given mathematical model. So data-driven provide usually only some basics of decision making, like some analytical summaries. For example, descriptive statistics. It's a good kind of summary for some data set, where model-driven DSS could usually provide some like recommendation, text statement, and so on about features which is retrieved from data, like diagnosis based on suggestions about medical diagnosis, based on some key value obtained from medical examination data. So document-driven DSS manage, retrieve, manipulate unstructured information in a variety of electronic format. So even collaborative work on Google Drive could be seen as document-driven DSS. So even that task related to first pair of classes, when you in collaboration create not all of you, also only those who were present, create a medical document altogether. So here is example of document-driven DSS. Could be sort of knowledge-driven DSS, provides specialized problem-solving expertise, stored as fact, rules, procedures, or in similar structures. And most widely used kind of decision support system in relationship to application in healthcare area. And in fact, when we talk about knowledge-driven DSS, so its technical representation very often could be seen as a sequence of logical condition, similar to those you have last class, as I remember. When it was necessary to make conclusion, for example, about normal weight or overweight, obese, based on some given patient data and body mass index. So here's exactly example how knowledge-driven DSS could work. Of course, simplified. Okay, and also last approach for classification, depending to development frameworks like text, database, spreadsheet-oriented. Yet again, we mentioned spreadsheets as solver, and compound DSS. So here is actually at least 3 different approaches for taxonomies already presented. Now, a few words about architecture or structure. It's how it's be composed of which parts for conventional DSS. So here is we have above simplified, below a little bit extended structure, but again, almost no difference. Major components, it's data management, model management, and user interface through which allow user to interact and utilize necessary components in order to turn data into some kind of decision. So data management components store information or provide interface with database, and which could be retrieved from organizational traditional data repository, from external sources, or even retrieved from personal insight and experience of users. Model management components had a representation of level, facts, or situation. For example, we can see like optimizational models or goal-seeking models, and user interface, of course, wants our user to interact with the system. That's simplified. But if you talk about real system, it could be very, very complex and built of a huge number of various components and interact with external systems and so on. So here is for kind of structures of one kind of medical decision support system, which support multiple type of data to be processed, and could be data entry could be provided in different way, different type of data can be stored within knowledge subsystem of this system. Also, its support contain analytical tool and provide various features for visualization of this data and so on. So exact implementation could be significantly complicated. In general, when we talk about DSS, we would expect some improving personal efficiency of staff members of organization, expanded in problem solving, facilitating personal communication, promotes linear training, and so on. So here is in general. But in details, it of course depends to areas of application, and right now to turn to solution of application of decision support system in medicine, and we consider such application as digital dashboard, clinical decision support system, and then a little bit we'll talk about information technology and development tool, which aids in the decision support system development, like MLM and RDN syntaxes. So here is given like a chart which show us modern approach to improve healthcare with a knowledge-driven mode of assistance, which involving data aggregation, decision support system providing, and adapting during treatment, with involving of data processing governance, and so on. So here is we have areas for involving decision support system and the DSS processing in medicine. And when we talk about areas which could be covered with activities of decision support, so here is we have that's red circle, which covers various activities on the clinical data processing, as well as organizational financial data processing, which could be covered with clinical decision support system activities. So regarding digital dashboard, enterprise dashboard or executive dashboards, it's kind of rather business management tool used to visually ascertain the status or health of business enterprise via key business indicators. As a result, it's actually by its meanings, dashboard, which visualize performance of organization by various indicators, and also could provide some notices, warnings, and hints about future development. So here is something like this one. Again, in my personal opinion, this kind of system barely could be considered as decision support system. Is rather management information system, but by statement of these companies, they deliver exactly decision support system. Okay, let's assume this for them. Obviously, to establish that system capable to works, we must already have implemented some like hospital or clinical information system, more general medical information system, which already collect any data for daily performance of our clinical facility. And only in this case, it's possible to employ some visualization system like this one, which give us provide us information with performance of our organization and give us be able to identify some tendencies, trends, and make decision about future development or some organization changes. So of course, major benefits of digital dashboards, that's its visual presentation of performance measures. So in case if the decision has to be made by humans, it's extremely good to have visual presentation, visual data available for us, and of course, various features like elimination of any duplication, identifying positive, negative trends, and so on. So every time when we have ability to summarize our data, so it's amazing and definitely could give some significant insights for executive staff, for managers about possible performance. But again, as for me, it's useful only for management case, not for clinical case. So let's move to clinical solution. Clinical diagnostic decision support system, interactive computer programs, which are designed to assist physician and other health professional with decision-making task. And the goal is intended to improve health delivery branches in medical decision with targeted clinical knowledge, patient information, and other health information. Here is important point in difference in this definition. That's not exactly in all case interactive computer programs. In fact, we have two major groups of CDSS system, one interactive and the second not exactly, but few words about this. So when we will talk about classical CDSS architecture, of course, here is we have this core given here, like data management, knowledge management, and dialogue management components, which are dedicated to deal with some external internal data. But usually we also need interface with other information system, especially medical or hospital information system to access patient data. And of course, user, or in this case, clinical professionals who are designated to make decision on this specific case through dialogue management component deal with all these three key components: data, model, and knowledge management component, which have to work together. In fact, most of modern CDSS, as I already said, they are divided into large group. So they are built upon electronic health records or designated to retrieve data from EHR system using some programming programming application interface or API. And here is we have three components of it, like knowledge base with store rules and guidelines, for example, about how to make some specific medical diagnosis conclusion, communication display alerts to user interface and accept input from clinicians, and inference engine, which here is key points, use health records, user input with these rules to execute decision support logics. And here is that's only question how health records information being used in CDSS, or via automated access, or will be required some manual input. And here is will be those two groups I'm speaking about. So let's summarize this point. Basic components of conventional CDSS consist of dynamic knowledge base, which contain all these predefined rules about diagnostics, and the inferencing mechanism, which is second significant part, set of rules that's derived from mixing and evidence-based medicine and implement through medical logic modules. Not exactly only by using this case, but if we want to establish interoperability, yes, must be used MLM and RDN syntaxes. But for proprietary CDSS, of course, conventional programming language have to be used. Same way, at this point, it's very difficult to provide, to make differentiation from clinical decision support system and expert system, because those features of usage of knowledge base as well as inferencing mechanism based on evidence-based medicine, it's also feature of expert system. So in this case, when we're talking about CDSS, we very often very close to meanings of expert system as well. And here is example how model-based CDSS could be developed by acquisition and processing some clinical observation about the patient, then turning it into some kind of mathematical model, which is like then has to be evaluated, but out of sample population have been used. So we have clinical data cohort for perform learning purposes, and then we have some testing cohort for perform verification purposes, then improve our data, and after that we can bring our model, mathematical model, to production and implement it into real clinical decision support system. So workflow I've already shown about yearly. Right now it's just a little bit another representation about how CDSS could access various information like patient data or some medical knowledges, and based on this deal with user who designated to make decision. And the following slide provides for you some kind of workflow or ideal scenario for implementation of clinical decision support system for providing assisted care for patient. And here is, we talk about this point, at starting point, performing some kind of measures from patient, which being aggregated into some storages, which, for example, designated for belongs to organization who patient has some like agreement about providing medical services, but it has to be performed some then data retrieved from patient had to be compared with disease rule bank for information about the hospital information system, which must incorporate previous medical records for this patient or common cases. And as a result, based on all this input, personalized CDSS have to provide some, for example, in case of emergency, some kind of alerts, which have to be delivered to a case manager, and in which is not exactly high-ranking medical staff, but based on its experience, its request have to be redirected to medical staff, or some immediate additional consulting have to be provided for patient. And again, physician have to review decision made by case manager, and then, if necessary, update decision. And again, some updated care have to be delivered to patient, so new data have to be retrieved, and cycle have to be repeated again after all these steps. So that's ideal case in form of dialogues. And how it could be look like practically? Much different and much simpler. So here is we have CDSS embedded into EMR software. That part is right. Even being entitled as CDSS. And it provides some insights about like necessary about actions that have to be provided, like vaccination, or, for example, some measures which have to be taken into account. We have some kind of slightly increased blood pressure, or something other have to be recommended or critically forced. Yet another case from another application, OpenEMR, this time a free open source solution. Previous was commercial, at the time free open source. Actually you will give an example of your such system during practical classes. And here is its colored clinical reminder. So DSS term has not been used here, but this part, this tool inside OpenEMR, it's exactly CDSS, because it's working exactly the same way, based on data already provided into patient medical card or into its encounter. CDSS clinical reminder provide insights about what has to be done, kind of assessment, measures, treatment, and so on, as you can see here. So again, it could be hidden under different name. Sometimes it's explicitly presented as CDSS, sometimes another term being used, but it's definitely CDSS. So, and another example, standalone decision support system. So this kind of system, it looks much more closely to definition of CDSS, like interactive computer program and so on. So Medal.org project, right now it's turned into commercial solution, despite this picture quite old, but project exists, project still under active development. Unfortunately, it's right now almost completely commercial, and just few small examples available without paid subscription. So it just proves that project very successful and very valuable in terms of medical diagnostics. In this case, it's composed of categories of different, like probably hundreds by now, different decision support system, which is organized into different categories related to some healthcare problem, like cardiology, pulmonary medicine, and so on. So obviously, medical staff must already have their decision, and in this case, DSS use it only to improve and provide some specific insight about some very narrow problem which could be found or could not when we need confirmation about our suggestion and need some for very specific and narrow problems. So it's again, in this case, this project very tightly fit to exact definition of what is CDSS. Each model, usually well documented, provides information about sources, so on which kind of medical literature, documentation rules it's based upon. Now, let's turn into some technical aspects about how such system like CDSS or as well as expert have to be made of. And one of possible approach is usage of medical logic models. Called independent unit in health knowledge base. That's combined knowledge required and definition of the way it should be applied for single health decision. So one MMM model usually provide some single specific answer. And it had to be developed by using Arden syntax, which is special grammar for describing medical condition recommendation in medical algorithms. Major benefits of usage Arden syntaxes, its ability to exchange medical logic model between different hardware and software solution. So now it's part of a health level 7 international medical standards. Unfortunately, have to make notice, unfortunately, a lot of system does not fully follow Arden syntaxes. So despite its incorporating standards, very often proprietary developers don't follow it. So It's very sad to hear, but still a lot of system support this, and it's give us benefits for exchange ready to use MLM. Again, unfortunately, usually it's only enterprise level medical information system, which is confined in large hospitals and available at very high price. So, example, how it could be how medical logic model could be consist of. So it's actually black box which designated to provide some input of patient data or analysis data and generate some kind of report. And here is example how it could be written with, again, XLS and the Java application. And so here is how we can all these text files give us turn into the general solution. And example of MLM model, so benefits of this, which is written according to Arden syntaxes. As you can see, major benefits, its usage of language, which is programming language, which is as possible, which is closest as possible as it can be to natural language. So here is we have only very few operators of programming language, and all other it's very similar to what we have to. And here is even take a look into logic, which give us very easy to be understanding the logic and implementation of some kind of calculation. Let some given variable be nearest and from where it is number and so on. So actually could be read and understand even without transforming it into programming code. So here is a good example of diagnostic algorithm. And actually available a lot of specific tools, for example, Arden syntaxes server, which assist developer to create MLM file, to create logic for MLM file, and later use it into medical information system. Unfortunately, this one does not a free software, required license to access it. And as you can see, yes, of course, we are talking about integrated development environment. So development tool, which even required some specific programming knowledge to implement it. And here is example, another example of MLM and the development. Here is we have. So again, in case if we have working MLM files within the system, it could be exchangeable, could become exchangeable and useful for all medical information system which support these syntaxes. So, in fact, we can consider, within current decades, we consider significant growing of implementation of clinical decision support system within different area. As you can see from this chart, so what is major areas of activities? If allergy alert components and rules, then clinical reminders and drug-drug interactions. So those take majority part in features of clinical decision support system, which is obviously and very easy to be implemented with logical, but even simple logical function and built into CDSS, like I showed example for OpenEMR before. So here it is. And here it was available. Global market, European market, but above global, below European market. But again, we are talking about. So here is we have prediction for next year, but we have even actually very steady growth each year on this. Okay, now time to turn into expert system. Definition, architecture, advantage, disadvantage, and few examples. So expert system or knowledge-based system, again, computer programs that contain knowledge and analytical skills of one of more human expert related to specific subject, and was developed by researcher in artificial intelligence. In this definition, as you can see, it's very, very similar to clinical decision support system based on knowledge. And actually, as I already noted, it's hard to distinguish them in this case. Just some few points. Expert systems have to provide expert quality advice, diagnosis for real-world problems. And what is the key points and maybe key difference? DSS made of to assist physician in decision making. Expert system have goal to replace a human expert. And here is maybe the only difference. If system provides suggestion, it's DSS. If system made conclusion, which user have to follow, it's expert system. And yes, of course, in modern time, it's no longer fiction like medical diagnostic expert system, and a lot of already provided and proves their some working capabilities. So if in the past I spoken to students, that's very often you will have to compete with expert system application. Unfortunately, right now, in area of decision making, you already compete with. So of course, expert system not dedicated to perform some activities, and fortunately for dentistry students, if people have some kind of those aches, those pains, and so on, so no way they must come to you to get necessary treatment. So for more more easy cases about kind of recommendation, for example, about apply some GGNS approaches or so, it's become more and more easy to consult with DSS and expert system. Here is given few examples of old but famous expert system dedicated for medical purpose. This one, the result still available. It's like free system and it's actually a good example to check yourself and see how such kind of system work. So in this case, when we consider architecture of expert system, again, it will be quite similar to those shown of clinical decision support system. It's composed by knowledge base, inference engine, working memory, and of course, user interface. So knowledge base, an expert system of rule base, its system has list of rules which determine what should be done in different situations. And those rules initially decided by an expert. So most time it's used term production rules, and each contain two parts: condition, action, pair. Condition: if something happens, then some specific action have to be done. And finally, what do we have? This if-then rules. So again, we turn back to all these things you already tried in last class. In this case, again, that small example of system you have developed to make decision about normal weight or overweight or obese, it could be seen as expert system depending who will use it. If physician input data of new patient, it's CDSS. But if ordinary user try to check yourself about what is my weight, is normal or not, non-professional will input data and got conclusion, it could be seen as expert system. So here is sometimes we have this point that it's not necessary to become to the expert system with DSS have to be something extremely complex. It could be quite relatively simple, but if it's fulfill some demands, it could be classified under designated class. So again, we can talk about very advanced algorithms of data processing, of knowledge processing. But if you will deep dive into this algorithm, very often it will be something related to if-then, or as well as statistical weighting and assessment of some probabilities. So here is just how example how we can build up this condition with objects that's value have to be tested, and we also can use logical function, basic logical function, and or not. So again, we refer to this task you already done. It could be simple, but it's as for me, nice training to demonstrate how DSS and expert system works. Content of working memory constantly compared to production rules, and actually content of working memory represent current clinical case which is under investigation. And when contents match the condition of rules, the rule is fired, action executed. So here is we have like significant loop, recognition act cycle, whenever condition is matched, it's added to the conflict set, and our rule which is currently matched, then conflict have to be resolved. Because usually when we talk about really complex system, it will be multiplier rules, that's concurrent case under investigation will be matched as possible to be involved in this. So that conflict sets have to be create number of suggestion about possible decision based, possible diagnosis based on given set of symptoms, and then have to be run a conflict resolution process, which will eliminate those kind of conflicts, which is not reliable or not related to given specific situation. So major problem, of course, in this case, it's to have relevant knowledge base, which is required very meticulous and careful filling with knowledge which have to be obtained from human expert, but organized, but knowledge engineers to be stored in expert system in proper way. And again, that's one more example of system management, and which is sign importance of system engineer and knowledge engineer and their roles. First of all, knowledge engineer provide expertise and encoding of domain expert and processing their knowledge to fulfill knowledge base, and system engineer working on the other system components to integrate it upon obtain its working solution. And so here is just small part of expert system algorithm, which is used to make decision about type of diabetes and conclusion about does this particular patient has specific type of diabetes and what it has to be done, what kind of treatment or continuous care have to be offered. in specific circumstances. And even these algorithms, it's very general, and significantly complex. So practical examples and practical solution. For example, here is we have multiply available on market, which is covered like expert system. Obviously, at the first place a system like dedicated to some financial analysis, because major direct benefits could be obtained in this way. And here is solution for medical insurance, which again based on information about patient, his health records, provide some automated solution for claims and allow to reduce health insurance cost, reduce cases, different fraudulent actions, and so on. So here is one solution. It's financial analysis related to clinical data, of course. Yet another Watson Health tools developed, it's already available on market for about 15 years, actually to utilize very complex algorithm to analyze written text and provide some specific search for answer. So for about 10 years, it's involved in development Watson Health components with aim to perform personalized treatment for a different type of cancer. It started 11 years ago, and idea was to integrate data obtained from various medical sources, different rules from diagnostic rules, medical publication, and made conclusion about recommended personalized care based on patient health records. So special components also developed for being involved in medical education process, or which allow to visualize clinical case and relationship between diagnosis, symptoms, and rules, as well as some conclusion, outcomes, and so on. So possible to visualize decision made for specific case, or as also review and even improve this. So here is information about, not very recent, but we have a number of solutions. By us 3 years ago, it's over 15,000 clients and partners, given 80,000 professionals and 200 patients, which consumes their artificial intelligence solution. Again, practical tool available by subscription for physician or hospitals. So major project, it's what's for oncology, with the objective to help physician quickly identify, give information in patient medical records, suffice relevant evidence, and explore a treatment option. So key features, it's extract key attributes from patient medical records, evidence-based treatment recommendation. It's involve oncology domain knowledge, which supplement from different medical journals, textbooks, and so on. And major benefits, patient-centric insights. So aim to improve patient care, provided again with fine relationship for specific patient data. And here is example how this tool looks like, how we process with clinical information. So here is given some measures, here's some key insights that IBM algorithm could identify from patient data, and we have some recommended treatment plan, option, timeline about how it's have to be worked, how it have to be delivered for patient. So, and here is comparison analysis, which is recommended or for consideration. So still, despite we are talking about expert system, it's rely on some kind of expert decision or professional decision. And here is given benefits, or as you can see here, given some notice about possible risks for this specific patient. So again, aim is to perform patient-oriented treatment based as closely as possible on condition of specific patient. And of course, final example, I cannot talk about this, ChatGPT, generative pre-trained transformer, so large language model-based chatbot that's developed by OpenAI, launched almost actually a year ago. Updated few times. By this time, here is very often user considers this like artificial intelligence system, but it's not exactly expert system, despite all this terminology. So here is it's true to see what to get things that they entitled themselves large language model, so and chatbot, which main features its analysis of text input or even voice recognition in recent version, and provide some language construction based on that claim. So even I have played some games with these things, and it was just immediately when I got access it last beginning of this year. I was amused that it's working not only with English, but it's even have capability to construct some useful statement in different language. So here is example to generate text in Ukrainian as well as English, but obviously it's much more richer in English language. And it's obvious consequence about how this architecture made of and what kind of data had been used for training of it. So, and already we have further development because ChatGPT-4 consequently, and last one, it's DALL-E model, had been developed and employed by OpenAI to improve performance of their tool. And here is given some examples of flowchart how conclusion had been generated by this language model for specific statement. Here is still not a lot of information they reveal about exactly how their model been trained and working. It's obviously because of aim of commercial application, and they already under Microsoft company had been broken by Microsoft, and now become more and more tightly incorporated into Microsoft ecosystem, including Windows and the Edge browser. So that's actually all notices. I see significant updates had been made this summer when various analytical and data processing tools have been added, which allow to extract data from files, images, and even video stream in order to provide some assertion and decision and search for data. So again, here is clearly important to understand that ChatGPT cannot be classified as expert system. Not even can be seen exactly as decision support system, despite language processing model, which is involved there, extremely powerful. And here is just recent also example how medical professions try to evaluate possibilities of use ChatGPT in medical diagnostics. So here is a live example I noticed recently, about months ago, application of ChatGPT in order to analyze medical images exactly. And here is more or less partially correct, but not exactly correct decision about specific case. Here is, in this case, ChatGPT algorithms properly identifies bone fracture, but not exactly not exactly correct that defines as specific diagnosis. So it's not this case of fracture, and here is explained by expert why. And same case we have with radiology, another radiology report, and also notices about like correct notification, smell, bone obstruction. Here is we have but so kind of clinical advice obtained by this model, like very debatable by from viewpoint of professional physician. And so what we come to, it's again very rare, very early article published almost immediately after ChatGPT has been released, which spoken that exactly about these two selected points. So usage of system like this one, healthcare, require careful consideration to ensure safeguards in place to protect against potential dangerous user. And that's warning, caution, and benefits. Yes, with constructive and our regulatory environment, deal basic language models could have transportive effect on healthcare, augmenting rather than replace human expertise. Again, exactly because ChatGPT technology, it's not an expert system, but being employed and incorporated into expert system, it could bring expert system technologies to absolutely new level, in my opinion, with ability for very advanced dialogue providing. Okay, so advantage, disadvantage of expert system. Obviously, after all this, it provides constant answers for repetitive decision, holds, maintains significant wealth of information, encourage organization, clarify logic, the decision making. But of course, disadvantage still be present, lack of common sense needed in some decision making. So here is from previous lecture on statistical hypothesis. Difficulties with creative responses, and here is sometimes we have difficulties with aggregating and organizing human expert knowledge. So in this case, if they are not always able to explain logic of reasoning, it will be barely possible to create expert system for that specific area. And even worse, if some kind of errors will happen when inside knowledge base, when it will be filled with data, it definitely will lead to wrong decision. And sometimes it could be difficult to adapt to changing environments and fight against of intentional attempts to fraud and falsification of information into the system. Okay, now we have like about 10 or so minutes remain. So a few words about artificial neural network as yet another approach which allow us to build expert system, decision support system, and so on. So under artificial neural network, we understand mathematical model, computational model, which is based on biological neural network and have to simulate behavior of this network with, of course, this mathematical approach. So it consists of interconnection with artificial neuron and process information using connections approach to computation. As a result, it's adaptive systems that change structure based on external information that's flowed through the network during learning phase. So here is how it can be identified, and we have some levels of, we have input node layer, which is much number of input we have to provide, and we are going to obtain some output, some solution. So, and what is important, so that's part we have to be defined, but we don't know about exact number of hidden nodes and their connections. That they being built automatically based on during network learning process. So here we have as intergroup nodes against the vast network of neurons in one mind. It's like simulation of one minds, of course, with much, by this time, with much less complexity. So it's tend to refer mostly neural network models employed in statistics, cognitive psychology, and artificial intelligence. So design with simulation of central network system in mind and subject of theoretical neuroscience. In software and implementation of artificial neural network, its approach inspired by biology has more or less been for more practical approach based on statistics and signal processing. So we turn from purely biological approach to statistical assumption. And a few words about theory. So INN models, essentially simple mathematical model defining functions. So we have function X defined as composition of other function, G item from X, which can further be defined as composition of other functions. So we split into multiply wires. And it could be represented as network structure with arrow depicting dependencies between variables. And widely used type of composition is nonlinear weighted sum, which is in fact a statistical formula, where occurs some predefined function such as hyperbolic target or other. And it will be convenient for the following to refer to collection of function as simply a vector. So here is we combine it with vector algebra. And final things will be something look like here shown at the top. Here is we have the composition of a function which depend between various variables indicated by arrows. From functional view, X is transformed into three-dimensional vector H, which is then transformed into dimensional vector G, and finally transformed into our output F. So it's viewed mostly common in the context of optimization. And second view is probability view. Random variable, which is F equal found on G, depends upon random variable G from H, which depend upon H from X, and depends upon random variable X. So here is we have two concurrent view about how to understand artificial approach. And here is its outcome of this approach, its possibility of learning. Given specific task to solve and class of function f, learning means using a set of observation in order to find such f asterisk which belong to f, which solves task in optimal way. And so cost function being identified for this case, which belong to a range of all numbers, real numbers. So it's measures how far away we are from optimal solution to problems that we want to solve. And on the training, it's essentially means selecting one model from set of our models that's minimize cost criteria. So once we achieve minimal cost, so we think our solution is an optimal. So and here is we have something like kind of block representation of network software. It's more general representation used by some network software, and how we can get this to generate our network. Of course, margin of the errors decline with enlarging number of layers or epoch in these terms, but of course it's led to growth of complexity of neural network and will require more powerful hardware in order to execute this solution. So application of neural network useful in such categories as function approximation or regressional analysis and time series prediction and modeling. So again, task a little bit known for you, except during your practices, we don't use artificial neural network, and we relied only on statistical methods. But same task could be solved by build an application, and even myself, I had some experience during my PhD thesis. I have tried to make prediction about how successfully students could be in their certification exam in Ukraine, in KROK, based on their success during exams in our university. So I have tried to solve this problem with help of building artificial neural network solution by statistical application. Was party of success. Actually, model was working, but it provide significant error margin for two groups of students, best and worst, which is actually main idea to identify those who are at risk to fail certification exam. So it was not completely successful research, but anyway, it was experience. Another task, classification, pattern sequence recognition, novelty deflection, and data processing, filtering, clustering, also separation and regression. And of course, areas as consequence of this, useful areas of application include system identification and control until automatic vehicle control. And it's quite successful right now because we have more and more self-controlled vehicles on our roads right now. Pattern recognition from military purpose to security purpose, but even ordinary face identification working properly, it's already in practical use, so we can use face recognition to access our like smartphones or perform authentication into different computer systems and so forth. Sequence recognition, speech, gesture, and writing text recognition also successfully are solved right now, but what is under tight development? It's again medical diagnostic visualization, various financial application, and data mining solutions. Okay, it's actually all I was going to present you during this lecture: introduction to decision support system, expert system, and some basics about artificial neural network. Thank you for your attention. Goodbye. Have a nice day.